My expectation was that by the time I saw you today, you would have finished the problems on assignment 37 that were not circled. So you should be pretty familiar by this point with just the idea of how to condense logs, when to water cycle, and when to drop the logs. And then all the fun stuff that happens after that, right? So you might think like, I think we got this on lockdown. Today's are just funky, all right? So let's get to it. Natural log of 6 minus the natural log of x equals 5. And FYI, as you write this down, if the 5 on the right-hand side said the natural log of 5, we would not be talking about this today. We would condense, drop the logs, and solve. So what every problem in today's notes is going to have in common, what they're all going to share is that they're not log droppers, and they're all going to require a fancy water cycle that we haven't done yet. And we are going to be reacquainted with somebody that we haven't talked about in a bit. So let's get to it. Step one, you know this. What's step one? Condense. Very good. So we're going to condense the left-hand side, and because it says minus, we're going to condense it into division. So we're going to have it as the natural log of 6 over x equals 5. And this is where I expect that we would probably kind of pump the brakes because something already is a little bit amiss. Something's off. What is it? Yeah. What do we do? That's what I needed to hear. And you didn't hear it because she whispered it at me. But Summer said that the natural log, let's not forget, is a log with a base of e. So let's take an extra line in our notes and let's remind ourselves that this natural log can and should be thought of as a log with a base of e. Converting a logarithmic equation into an exponential requires that we have all three pieces. Piece one is down here, and he gets raised to the power of that, and then we set that equal to that. It's always going to be in that order. Base to the power of logarithm equals argument every single time, and no one can be missing, otherwise we'd be missing a piece. Having said that, um, let's start the cycle. What are we going to write first? E to the fifth equals 6 over x. What you have to remember about E, and I got to remind myself, keep this short, keep this short, keep this short, is that E is not a variable. For the next half hour, the next day or so in this class, we're going to treat him like a variable. We tote him around as if he were like an X or a Y. Because the worst thing you could possibly do right now is type into your calculator E to the fifth power. It's a number. Don't forget, E is not a letter. E is a number, and it's roughly equivalent to 2.71828. FYI. We'll be using our scientific calculators today. So if you still haven't procured one, well, you'll just kind of have to sit and watch. But for those of us that have them, TI-30, Casio, TI-84, whatever it is that you've decided to buy, we're going to use them in a little bit. So just be advised that there's going to come a point where I'm really interested to know some kind of rough ballparky calculations that involve E. But for now, I just wanted to remind you that E is not a variable. Like I, it is a number. It's a very special number. And so let's get back to algebra. So our equation currently sits like this over here. How do we finish the job and solve for x? Right. Multiply both sides by x. That's never going to be something that we debate. C fraction, kill fraction. So we multiply both sides by x, and we get e to the fifth x equals 6. It's weird. Like you might be inclined to write x e to the fifth, but remember that e to the fifth is not a variable value. So all mathematicians would tell you that your number should go before your variable when you're multiplying. So e to the fifth x equals 6, and then how do we finish the job and get x by itself? Correct. And we're done. So if you have a calculator, borrowing one of mine isn't going to help you today because those will not, they're not scientific. But if you have a calculator, what I want you to do right now is type in 6 divided by, and somewhere on your screen, you guys probably have a button that says LN. And I'm guessing that above that button, you have a function that says something like e to the x, or depending on what model you have, you might have e to the. Those both mean the same thing. So access that feature on your calculator, get good at it, get used to it. Because what I want to do is I want to lay eyes on approximated values of this because we have to, don't forget, we have to test our answers to see if they break any rules. Okay. So we have 6 divided by e to the 5th power. So you're just going to type into your calculator 6 divided by e to the 5th. And I'll do that right along with you. It's very, very small. And why do you suppose that is? E is between 2 and 3. And if you take something that's between 2 and 3 and raise it to the 5th power, newsflash, you get a big number. And if you take a small number like 6 and divide it by a big number, you get a small number. But that's not, to me, what's most important. What's important is that this number right here is positive. So as we go throughout this lesson and we go and we put these numbers back in, sometimes yes, sometimes no. Sometimes just knowing that something is positive is enough. Sometimes you need to know a little bit more. Sometimes you need to get in there and dig a little bit deeper. So just knowing that it's positive, I'm going to head back up to the beginning. And if I put it in this yellow box, do I cause any problems? Then we can circle it or put a box around it and say our answer is that x equals 6 over e to the 5th power. These answers involving natural logs are going to be, they're going to feel undone, but that's just the nature of the beast. Now, if this were an application problem involving like exponential growth or decay or financial something, this or that, then it would be a good time to put it in your calculator and round it off. You know, if the question was like, how many days or how many bacteria will there be after blah, blah, blah days, then that's a good time to put it in and actually come up with like numbers. But for the sake of purity, we just leave it like that and move on our way. Example 2. The natural log of x minus 4 minus the natural log of 7 equals 4. Step 1, condense. And let's see if for the entire rest of this lesson, if we can not do that step. All right. We know what's coming. We know that the natural log is a log with a base of e. So let's just imagine it there and tell me what would this be if we cycled it out and converted it over? What would it say? There you go. Good job. Got it? Okay. So if you want to show that intermediary step with a log with a base of e, that's fine, of course. I don't care. Just trying to save a little bit of time along the way. So let's get to it. Algebra kicks in. What do we do? Multiply both sides by 7. What does our next line say? Yep. And it's weird because 7's a number and e to the 4th is a number. So in this case, putting e to the 4th 7 would feel weird. So we do what Ollie said, and we would write it as 7e to the 4th. If 7 were a variable, we would put it in the back like e to the 4th x, just for the record. So we have 7e to the 4th equals x minus 4. What's up next? Just add 4 and we're done. That's it. So we have x equals 7e to the 4th plus 4. And so again, I mean, listen, here's the bottom line. If you think of e, if this is for those of you who don't want to use a calculator, if you think of e as 2 to the 4th is 16. If you think of e as 3, 3 to the fourth is 81, right? And so E is somewhere in between there. It's probably closer to the 81. If I had to guess, I'd say probably closer to like 50 or so. Okay. So if you take 50 and you multiply it by 7, you get a big number. And then if you add 4, you get a slightly bigger number, right? Bottom line is my potential answer at this point is looking like a pretty big positive number. So we're going to head back up to the beginning and we're going to plug it back in. And do you see any issues if we put it right there? I would have an issue if my potential answer came out to like 3.6. Then I'd go, uh-oh, busted, right? Because 3.6 minus 4 goes negative. But man, we've got plenty to cover minus 4. We have no issues with this guy at all. So he can have a box. And by the way, potential spoiler alert here. I'm pretty sure that every answer we get for the rest of this, I think they're all going to work, quite frankly. And that don't make assumptions based on that. It was just poor planning on my part. Okay. Next one. Natural log of 3 plus the natural log of x plus 3 equals 2. Condense and condense by multiplication because of the plus sign. Remember that a plus in between your two logs says multiply my arguments together. So we get a natural log of what? Of what?
Good.
Good. Everybody okay? If you multiply 3 by x plus 3, you get 3x plus 9. Stop me if you have a question. Okay, what's next? E squared equals. Gorgeous. Next up.
-9e squared.
No. Next step. Yes, you do. So don't say -9e squared. If I'm subtracting 9 from both sides, it is not multiplication. It is e squared minus 9 equals 3x, right? A -9e squared would imply that we were multiplying, which of course we're not. Still good? Yeah, yeah. Divide by 3, and again, just leave it intact. We'll wreck it at the end when we need to have a ballpark of what e equals. Okay. But for now, just leave it alone. We're just going to say x is equal to e squared minus 9 divided by 3. So, common sense bomb incoming, about to drop on you. E is less than 3. Do we all agree with that? And 3 squared is 9. So can we all agree that e squared being less than 3 has to be less than 9? Then do we also agree that e squared minus 9 quite literally has to be a negative number? And can we also all agree that a negative number divided by a positive number is a negative number? And the reason I'm telling you this is because if I don't want to use a calculator, just that information might be enough for me to get through this. So let's see what happens. I have no idea. So E is a slightly negative number. I don't imagine it's all that exciting. So let's go see what happens. And you can see in a case like this that that little talk I just had with you was not enough. Because this leaves right here a little bit of a question mark in my mind. Right? So sometimes just ballparking it isn't enough. So I kind of put a question mark here and I say, you know what? What I really want to know here is I want to do a little bit better than my slacker teacher at this point in time. And I'm going to grab my calculator now and I'm actually going to type in e squared minus 9. Make sure you hit enter after you do this. If you don't, you will miss it 10 times out of 10. Okay, so I have to hit e squared minus 9, and that's going to come up with negative 1.6109. And with modern calculators, you don't have to type anything again. You know this. You can just literally hit divided by, and your calculator screen will say ANS, which stands for previous answer, and then it just says divide by what? And then you divide by 3. And this is why I'm interested, is because this answer came out to approximately equal to negative 0.54. Now, when I take that number and I go and I plug it back up in at the beginning, do I cover? Am I covered in the green box?
Yep.
Yep. I go back into the positives. Again, this conversation ends differently if when I put all that e squared minus 9 over 3, if I put that in my calculator and it comes out to negative 3.2, then I plug that in the green box and I go, oh, you're no good. You kept a negative. But so sometimes just kind of half-heartedly ballparking it maybe isn't enough. But anyways, he's fine. And again, I kind of spoilered it for you earlier that I think they're all just quite frankly going to work. But our answer for this one is x equals e squared minus 9 over 3. And that marks the halfway point. Are we doing okay? Nothing to it, right? Right. These last ones, maybe not this one, but a couple of the last few are going to involve uh, some rooting, some exponenty kind of stuff. And I don't know if it starts here or not. So let's do this one. Natural log of x plus 6 minus the natural log of x minus 4 equals 6. Let us condense. It's going to be division because of the minus sign. Good job. So we get a single natural log whose argument is the arguments of his predecessors in order. X plus 6 goes on top, x minus 4 goes on bottom. Next step. Yes. Strongly encourage that you put these yellow parentheses. I know I strongly encourage a lot of things, and some kids are just pretty like stubborn. So take it or leave it. Putting the parentheses only not only makes it more proper, but it will remind you to do what we're about to have to do, and that is distribute. So don't forget. Here we go. On the right-hand side, these are, of course, going to cancel out. And on the left-hand side, what are we going to get? Correct. We're going to get e to the 6th x minus 4 e to the 6th equals x plus 6. This will be your first sniff of confusion or difficulty perhaps here today. So what problem, what issue do you see with this? I have no issues with double e's. They're not variables. They don't bother me. They're just numbers. My issue is that I have x's over here and over here. And this has come up in our past together in our year before this, maybe. But at some point, you have to be aware that sometimes the variable you're trying to solve for will be in two different places. And there's a trick to this. And the trick to this is to bring them together on the same side and pull out a GCF copy of them to turn two things into one. I'll show you what I mean. So I am going to leave my e to the 6th x right here. I'm going to take this purple thing and I'm going to bring it over to the left. And the reason for that is because I want my terms that contain my target x to be on the same side so that I can do what I'm about to do. But then I want to clear the path. I want to get everybody else out of there. And so I also now have to turn around and take this 4e to the 6th and say, skedaddle. So on the right-hand side, we're going to be left with 4e to the 6th plus 6. It's at this point that you factor, not normal factoring like you're used to, two sets of parentheses, what multiplies to make this and this. This is just what we call common factoring. You'll notice, of course, that you could anti-distribute an x out of both of those terms, right? If something's in two places, it had to have at some point maybe been distributed to get like that. Like one thing becomes two when you distribute it through. So we're going to do the exact opposite of that, and we're going to pull the x outside, thereby, through sheer wizardry and magic, turning two things into one, which is the goal. What's left over if I pull out the x? E to the sixth minus 1. If that feels like a waste of time, you're just not paying attention. I need x to be in one spot so that I can solve for him like an algebra student would. This is unmanageable if he's in multiple places. Like, which one do I solve for? You don't. You consolidate into one and then use very, very basic algebra to finish the job. And so our final answer is x equals 4e to the sixth plus 6 over e to the sixth minus 1. And if you're super math vibey, you might be inclined to ask a question like, is the bottom a difference of squares? And it's just really not even relevant in this case because he's not a variable value. It's just, we're just toting around numbers here. So none of that matters. So you're going to go to your calculator again, and you're going to type in 4e to the sixth power plus 6. You must hit enter right there. Unless you're good at using parentheses, which a lot of people just are not. So I'm going to type in 4e to the sixth power plus 6. And I'm going to stop right here. And I have a really big number, by the way, which turns out I really don't care about. I'm just going to write it down so you know if you're on the right track. I got 1,619.72-ish. Good. But it doesn't matter because with that on your screen, you're going to hit divided by right now, and your screen is going to pop up these 3 letters. And again, that, remember, is just short for previous answer. So you ask your calculator to take your previous answer and divide it by. And then you're going to do some parentheses. These red parentheses are critically important. You need to tell your calculator when you want it to divide by a bunch of stuff. Otherwise, it'll just divide by the first thing it sees and then carry on by subtracting 1 later when it's done. You want to bunch it all together. So we want to put all of this e to the sixth minus 1. So I'm going to hit divided by, open parenthesis, e to the sixth power minus 1, close parenthesis. I got about 4.02. So that's what I'm working with here. My answer is about 4.02. And you'll see in a second why it's so important that we know that, because if that's our understanding of what this number pretty much is, and I go back to the beginning, you could pick either of these initial logs. But I mean, look how close you are. Let's say you pick the one I'm underlining in green, which you probably wouldn't. Most people work left to right, but let's just hypothetical, right? Our answer is about 4.02. If you put 4.02 right there, what's 4.02 minus 4? Positive. Good, right? And then, of course, if you put it in the first one, 4 plus 6 is 10. So we're fine there. But man, it's important to be able to get in and look and see, get a good idea of what something actually equals. Because had that been 3.9, again, this conversation ends differently than it just did. Okay. So it passed. Surprise, surprise, right? So we can say our final answer is that x equals 4e to the sixth plus 6 over e to the sixth minus 1. Full disclosure, these last 2 answers that we're going to get are not going to match the answer key. I don't want to talk about it today. Do you guys remember that rule, how we're not allowed to leave square roots in the bottoms of fractions? We're not going to address that today. Okay, we're going to tackle one thing today, and that is just how to do the dang problems. Tomorrow we'll go down the road. After you finish the problems, we'll go down the road of how do we make these mathematically proper. Okay, so just bear that in mind. The answers we're about to get are in need of a little bit of work that we'll put off. 2 more. Natural log of 3x squared plus 4. If condense it into division. So we get the natural log of what?
3x plus 4.
3x
3.
squared
3.
plus 4 over 3. Nice. Next step.
7 equals 3x squared plus 4 over 3.
Still good? All right. So we've left the land of logarithms and all that, and now it's just fundamental algebra. Do I know how to add it, or not how, when to add, when to subtract, when to multiply, when to root, all that kind of stuff. So what do we do first? We multiply by 3, and we do it on both sides. And I'm going to do a side change on you here because I like my x's on the left, so you'll just have to deal. So I'm going to put 3x squared plus 4 equals 3 e to the 7th. Cool. Now follow your instincts here. There are 3 things we have yet to do. It doesn't look like we're 3 steps away, but we are. What's the first one? Subtracting 4 is a money answer, right? So that's step 1, is we know since we were like 13. Clear the stragglers. Minuses and pluses, get out of here. So we're going to be left with 3x squared equals 3 e to the 7th minus 4. Next step, divide by 3. You have good instincts. I'm very impressed. So we're left with this. We're at this crossroads. We have x squared equals 3 e to the 7th minus 4 divided by 3. Last step. How do you get x by itself? Root it, right? And it's a square, so we square root. And when we do that, we get x equals positive negative. And this answer is not okay. It's going to be okay for today because I don't want to bite off more than any of us wanted to chew. So today we're just going to stomach that. But I hope you understand that that answer technically is a little bit illegal because it's got the root 3 still in the bottom. But tomorrow we'll fix this guy. So you can grab your calculator and let's start typing. So when you hit the square root button on your calculator, it will say this. Almost all calculators have agreed upon that notation. So your calculator will say, okay, boss, square root of what? And what you want to do now is type in a new parenthesis here and put in your 3 e to the 7th minus 4. And then you want to divide by 3. And then you close the purple parentheses. The purple parentheses are your way of telling your calculator that, hey, calculator, everything from point A to point B is inside the square root. Okay? And the red parentheses are key because we need to tell the calculator that all that is going at the top of the division problem. Everybody get it? I got 33. Does that match what you guys got? 33.09531425. Good. So let's ballpark this sucker and say right now our answers are roughly positive and negative 33. If we need any more accuracy than that, then we'll come back and revisit. So let's see if we're going to have any issues with positive and negative 33. Head back all the way to the beginning. Do you see any issues arising? I don't either. Yeah, man.
Since x squared, would it not matter what the answer is?
That is correct. Yep. In fact, even if x somehow came out to be 0, it wouldn't matter. So y'all take Owen's point there? Yeah. What happens when you square a negative?
It becomes a positive.
Right. So I mean, it's inescapable at this point.
Whatever 33 squared is, it's much larger.
No, I don't think that's his point. His point is that it doesn't matter. This yellow egg is going to be positive no matter how hard you try to unpositive it. And a positive times a positive is a
Yeah.
positive.
I wasn't saying like that.
Okay.
I was just saying anything else.
Right. Yep. We good? And again, I already spoiled this earlier, but yes, we can put a box around this and let's head on to the very last. Oops, the very last problem. Put the box in the wrong place. Feeling it? Uno mas. Natural log of x squared plus the natural log of 6 equals 8.
And then condense it down by multiplication.
Mm-hmm. So it's going to become one logarithm. Natural log of what? 6x squared. Next up.
E to the 6 equals 6x squared.
Why did I put x there? That was supposed to be an 8.
E.
So it's e to the 8th power equals. Whoop.
E to the 8th equals 6x.
Much better. It's just algebra. What do we do now? Divide by 6. And we are left with x squared equaling e to the 8th over 6. What's x? So x is equal, strong equals, horizontal bars, confident equals, positive, negative, root e to the 8th over 6. Now, what is x kind of equal to? Let's all get eyes on that, okay? Let's all make sure we come to consensus, okay? Not that we don't trust you. So but good practice with your calculators. So we have the square root of, and then I'm going to do e to the 8th divided by 6. And I got what he said, 22.3-ish. But again, this could come down to a situation like what Owen pointed out. And I've got no issues with you working smarter, not harder. So it's just kind of good to have in your back pocket. So he's around 22-ish. Let's go back up and have a look-see. And it's the same conversation as before. Again, there's almost no way. There's only one number that would make this have no solution. What would it be? Say again?
0.
Yes. If by chance at the end of this problem we got x equals 0, that would be the only thing that would make us say no solution. Because if you put any negative number in there, it becomes a positive. If you put any positive in there, it becomes a positive. We got no issues with anything. But 0 would be the only bad guy. And we didn't get 0. So we can just go ahead and take this and box around it. Oop. Got it. All right, that was pretty efficient. I think I was quicker. So you guys have about 10 or 11 minutes. I'd like you to get back to work on assignment 37. And let me know if you have questions. I'll keep the recording alive, but paused. Yes, Cody? Not yet. Would you like it on Canvas? I'll put the answers on Canvas, no problem. Just one thing, and I got to say this before I hit pause. If I put the answers on Canvas, you are going to notice that your answers, a lot of times, to the circled problems are not going to match. And that's because of what I said earlier. The computer is rationalizing its denominators. We today are not worried about it. So if you do the circled problems, just watch out and let me know if they don't match. So I'll still put them up there, but don't give me grief about it.